Welcome to today's video on the origins of the universe. What if the universe isn't an explosion inside space, but the beginning of space and time themselves, expanding everywhere at once? That core idea is what people call the Big Bang, a model where the universe starts hot, dense, and smooth, then cools and expands over time. The name Big Bang began as a cheeky nickname on the 20th century radio program, but the model stands because measurements support it, not because of the nickname. We see three big clues that point to a hot, expanding past stretched light from distant galaxies, a faint microwave afterglow across the sky, and the early abundance of the lightest elements. It's not a fireball with a center that we could fly to. It's the space between far apart places steadily getting larger so that very distant galaxies grow further apart. When space stretches, the ripples of light traveling through it stretch too. So each light arrives longer and therefore redder than when it was emitted. This is called redshift. Redshift is simply how many times the wavelength became on the way. If the light arrives twice as long, the redshift is 1. 4 times as long, the redshift is 3. This time stretch shows up in real data from distant stellar explosions. Their brighten and fade pattern is slowed by exactly the same factor of the color shift. Across space, you can picture redness as motion through space. But across cosmic distances, it's more accurate to say space itself is stretching. Here's the meaning of the famous distance speed relation in plain words. The further a galaxy is, the farther it appears to recede in steady proportions of its distance. The equation would look like this, where h is the Hubble constant. Think of it like an interest rate on distance. For each million years, at about 22 kilometers per second of moving apart speed. This large-scale expansion doesn't rip you out of your chair. Local gravity, electric forces, and atomic bombs dominate on small scales. So expansion shows up over huge distances. How did this idea take shape historically, and why mention it? Because the path shows how science works. Evidence first, then theories earn their names. Vestal Slipher measured galaxy spectra and found many were redshifted. Henrietta Leavitt discovered how special pulsing stars convey distances, enabling a cosmic yardstick. Georges Lemaitre, a Belgian physicist and Catholic priest, connected these threads, arguing in 1927 that the universe is expanding and the distance and recession speeds grow together. Edwin Hubble's distance work helped reveal the overall pattern, and later tests confirmed other predictions of a hot beginning. First prediction, a sky-filling afterglow from when the early fog of plasma became transparent. Today, we see that glow as extremely cold microwave light, just a few degrees above as absolute zero. Second prediction, lots of hydrogen and a big helping of helium from the first minutes, exactly what we find in the most pristine regions, plus tiny traces of deuterium and lithium. Could redshift be from light just getting tired or dust stealing energy? Those ideas fail key tests. Distant explosions fade more slowly, in time exactly as their color shifts, just what science predicts. Another common worry is faster than light recession at great distances. That's allowed here because nothing outruns light locally. It's the separation of far off places that grows. Now, an honest boundary of the model you should hear plainly. As we rewind, into the earliest distances, our tested equations become trustworthy. It's not that nature breaks the rules, it's that our rules, general relativity and quantum mechanics, aren't yet unified for that extreme regime. So, for a tiny sliver at the beginning, we do not have a single tested theory of what happened. This is an active area of research. Different worldviews offer stories about ultimate origin and meaning. Science narrows itself to claims that can be tested, repeated, revised by anyone with the tools. Those other stories can matter for identity and purpose, but when a claim is about how nature behaves, science asks for evidence that strangers can check. My personal worldview is that we may be living in a simulation, but I have no scientific evidence for this, and I'm not fully certain. So it stays philosophical, not part of this course's evidence based story. Redshift allows us to read the universe's diary in color. Looking far is looking back. The light carries the record of how much space has stretched since it has left. Tie that stretch to a distance measured by a calibrated yardstick. Plot many galaxies, and a straight trend appears. Further means faster in steady proportion. Put the clues together, and the picture hangs tightly. Space expands. Early space was hot and dense. Light is stretched. An afterglow fills the sky, and light elements are abundant. Expansion doesn't act inside your body or bound systems. Galaxies, solar systems, and atoms hold together while vast intergalactic distances grow. Here's a profound counterintuitive consequence to emphasize. Because expansion is accelerating, some of today's galaxies are slipping out of view forever. Their new light will never reach us. That means that the observable universe is slowly emptying out in very long timescales. Distant galaxies will fade, redden, and vanish beyond the point of no return as space stretches. Over human history, the sky looks similar to the naked eye, but in principle, the edge of what grows with time as more distant light arrives. Ancient observers had less time for that faraway light to reach Earth, so their observable universe was smaller than ours today. Now, add a twist from accelerating expansion. Some galaxies are slipping beyond a horizon, so their new light will never reach us. That means far future observers will watch the deep sky empty out. Distant galaxies will fade, redden, and vanish beyond view, leaving only our local group bound together. We live in a rare middle window where deep clues are still in reach. The afterglow of detectable and far galaxies are still visible for now. Why this matters beyond the cool space fact is personal and practical. It trains you to ask what would prove this wrong and to trust conclusions most when independent clues agree. It also reframes the night sky from decoration to history you can measure. Like tree rings in a forest, the colors and brightness record time, temperature, and change. You can appreciate that Lemaitre's role shows methods and meanings can coexist. Science asks, how does nature behave? While people can seek meaning in other domains without mixing the rules. The takeaway? To carry forward a clean and testable space expands, light records that expansion as redshift, and multiple measurements convey the same story. Quick recap. Big Bang equals the beginning of space and time, hot and dense, then cooling and expanding. Redshift refers to the stretched wavelength. Double the wavelength is a redshift of 1. 4 times would be a redshift of 3. Further means faster in steady proportion. Rule of thumb, about 22 kilometers per second added for each million light years of separation. These three pillars of evidence agree stretched light and sky-wide microwave afterglow, and a universe rich of hydrogen and helium within the first minutes. On its boundary, the earliest instant remains unknown to current physics because our best laws aren't unified there yet. And the horizon lesson to remember? Ancient observers saw less than we do, and future observers will see less than we do as accelerating expansion pushes galaxies beyond view. To close, we need to think clearly, weigh multiple clues, and hold big claims lightly until big evidence arrives. This is how we keep our brief moment in the cosmos meaningful. Thank you.